In this video, we are going to go through YJC 2010 Paper 2 Question 7. This is a question on hypothesis testing. A manufacturer claims that the breaking strength of a climbing rope is normally distributed with mean 1702 and standard deviation 105. Just by reading this line, the first thing that comes to my mind is that, and since I know it's a hypothesis testing question, is that later on I'm going to be using z-test. This 1702 is my mu naught, and the standard deviation they're talking about here does not derive from a sample, so really this is my population standard deviation, which is denoted by sigma. A random sample of 10 climbing ropes is tested. This 10 here is potentially tricky because a lot of people would think that if sample size is small, I have to use a t-test. This is not true because my climbing rope, the breaking strength follows a normal distribution, so no matter what, I will be using a z-test for my hypothesis testing. The breaking strength of this sample is given by x bar. So they want us to carry out at 5% level of significance to determine whether the manufacturer's claim is valid, meaning I'm going to be doing a two-tailed test because the manufacturer is just claiming that the mean breaking strength is 1702. So do two-tailed test, and then I'm supposed to find the range of possible values of x so that h0 is rejected in favor of the alternative hypothesis. So this is a question where we are given conclusion, find the range of unknown. To do the question, the first thing we do is h0, state the hypothesis, mu is equals to 1702. The alternative hypothesis is, we said earlier, is a two-tailed test, so mu is now equals to 1702. Use a two-tailed z-test at 5% level of significance. And then under h0, assuming that h0 is true, I don't have to use CLT in this case because my x is normally distributed. So my x bar follows normal distribution 1702, and then my population standard deviation or population variance 105 square divided by 10. For such question, the next thing you say is for h0 to be rejected, we need z-test has to lie within the critical region. To find out exactly what are values that my z-test can take as part of working, we should draw the bell curve for z. Okay, critical region, because it's a two-tailed test, so they are on both sides of the bell curve. This is 0.025. This is 0.025. My z critical, if I take inverse norm of 0.025, you'll find that this should be negative 1.95996. And this point here is 1.95996. So, basically, since I need z-test to be inside the critical region, we need z-test to be less than or equals to negative 1.95996, or z-test has to be more than or equals to 1.95996. My z-test, the formula for it is x bar subtract mu naught, in this case is 1702, divided by the standard deviation of x bar, so I get square root 105 square divided by 10, less than or equals to negative 1.95996. Or z-test will be x bar subtract 1702 divided by square root 105 square over 10, has to be more than or equals to 1.95996. Solving these two inequality will give us the answer. So I think the important part for this question is to note that my breaking strength of a rope is normally distributed. So, and we are tempted to use t-test because sample size is small, but no, we don't. We only use t-test when we don't know it's a normal distribution. In this case, we are given, so we use a z-test. On the other hand, for the next part of this question, the manufacturer believes that adding a special chemical to the ropes will increase the mean breaking strength and change the standard deviation. In this case now, we are taking a random sample of 10 such ropes. So to do this part, actually the first step we should define my random variable as let y be random variable breaking strength of a new rope. And since it is not mentioned that the breaking strength of these ropes follows a normal distribution, later on we need to use t-test. Okay, and the reason is because we do not know that the breaking strength of these new ropes follows a normal distribution. And I do not know the standard deviation of these new ropes, so I have to use a t-test. Because population standard deviation is unknown, sample size is small, and it is not mentioned that the breaking strength of these new ropes follows a normal distribution.